All right, so let's take a look at the last section of stuff from the chapter, which is exceptions. So we talked about this before. The int3 is one type of exception. There are a lot of other exceptions. Exceptions are flags that are raised in the processor when it has a special condition that requires special treatment, like you access memory that you're not allowed to get to, a memory that is not reserved for your process, divide by 0, and so on. So there are first and second chance exceptions. When you have a debugger attached, the first thing an exception does is hand it to the debugger and say, well, do you want to handle this? Because it might just be an int3 for the debugger, or it might be some other exception which the developer is trying to fix. That's why they're running a debugger. So the debugger gets the first chance. If the debugger can't handle the exception, we can choose to pass it on to the program. And this would be if you're a good programmer and you actually handle exceptions in your code. So the debugger will say, do you want to look at this? If you know, I'll let my code handle that. Then the code will try to handle it. And we'll have, in the exploit development class, we do a lot of projects. We do a structured exception handler exploits, where you do in fact have to pass exceptions back to the program because you're hacking it and altering the data stored in the structured exception handler to take over the machine. All right, that's the second chance. If the application doesn't handle it, then the debugger gets a second chance to handle it, because at this point, the program would have crashed and popped up one of those messages from Windows saying, oh, your program has crashed, do you want to pass it to a different debugger or something? So that means your code, even your code had a chance to handle it with your developer's exception handling code, and that failed. So that's the second chance. In malware analysis, you can often ignore first chance exceptions. Second chance exceptions are what matters, because of course, one fairly common thing is we do in exploit development class is that malware deliberately causes an exception in order to gain control of the processor. So it's very likely going to handle the exception, and you only care about second chance exceptions. So int3 is the software breakpoint we're using all the time. That doesn't mean anything's wrong. It's just a exception to bring you back into the debugger. Single stepping, you can step one by one, and that it of course does. You can implement it as an exception. Now you can set the trap flag in the flag register, and then it will automatically stop with causing exception after every step, or you could just keep replacing it with CC. All right, and there are memory access violations. This is if you try to use memory at an invalid address, and it happens all the time when you're developing exploits. All right, and that's violating privilege rules. So memory access exception means attempt to access memory in an disallowed location, and violating privilege rules would be trying to execute a kernel mode instruction from user mode, or trying to execute code in a region of memory that does not allow execution. All right. So there's a whole lot of exceptions. Here's dividing by 0, the single step debug exception. Here's the breakpoint, and there's a lot of them. You can go online and find a chart of them all. There's a bunch of exceptions. All right, and so you can modify execution with a debugger. What we've talked about now is mostly what I do. You just put a breakpoint, you zip to the breakpoint, figure out what's going on, but you can also modify the execution in a debugger. You can change the value in the registers, you can change the instruction pointer to jump over code, and so on. You could avoid a function call by setting a breakpoint and skipping over it. Of course, if you do it sloppily, you'll crash the program, but you can modify execution in a debugger. And what we're going to do is modify it in debugger and save the modified executable and now have modified code. That's what we're going to do with Ollie. And that's, of course, what people who want to cheat at games like to do. You can make a hacked version of the game that's different. For example, getting past the activation, or giving yourself more lives, or making the enemies slower, things like that. So you could test a function. You could run to the code, and then you could test the function all by itself by just loading up the stack and registers with the parameters and running the function without running the code that gets there. All right. And so in practice, one example in your book is this is quite common. If you make malware in Russia and you can advertise it as a product and sell it, and the Russian government will not only allow that, they will protect you and encourage it. You can advertise, we will hack into anybody for 30 bucks, just pay us the money, and we will give you like a program with a GUI where you click on this button and it hacks into your target. And they're perfectly happy to sell you that, but the rule is you cannot attack Russians with it. So as long as you attack non-Russians, you're okay. And if you are a nation state, like the NSA, then you are trying to attack certain people. Like when we attacked Iran, hit the nuclear isotope separators, there was a targeter on the Stuxnet attack that would read the serial numbers to see who we were about to attack and only attack them if they were our target. So this is quite common. And one common technique is to just look at the language on the machine. So here's an attack where if it finds that you're in Chinese, it just uninstalls itself and does nothing. If it's English, it just pops up a message. And if it's Japanese or Indonesian, then it destroys the hard drive. So this is somebody that didn't want to hurt the Chinese, but really wanted to hurt the Japanese. And this kind of stuff is fairly common. So if you wanted to run this stuff, and then what you could do is you'd find the assembly language that does this. It calls get system default LCID, which is a language setting, and then it gets a value. 409 is English, 411 is Japanese, and so on. Keyboard layouts, yeah. Anyway, so it gets this number from the system saying which version of Windows are you running, which location is your localization set to, and then it compares it to values. So what you could do is you could just put a breakpoint here, go here, and then load the variable EAX with, or knock out the part you don't want. Here's where you could just control it without, if you, for example, were working on an English machine, but you wanted to see what it would have done to a Japanese machine, instead of having to load up a virtual machine and set it in Japanese and now you can't read anything, you could just modify the execution at this point to make it do what it was going to do to a Japanese machine, even though I'm on an English machine. Anyway, that's the sort of thing you might want to modify execution to accomplish. So here's the last cahoots. All right, I think that's pretty much everybody. I'll give it another 5 seconds. All right. All right, so which one of these will handle exceptions during normal program execution? The structured exception handler is what Microsoft programs have. They have this pointers to code which handles exceptions when you're not using a debugger. All right. All right, what kind of exception does not stop code execution and can usually be ignored? All right, it's a first chance. I'm not sure I like that description very much. In practice, it does stop code execution, but you can just pass it back. But anyway, that's why these cahoots are extra credit. They're often not perfect. Anyway. All right, a Ring 3 process tries to access hardware directly. What will happen? All right, that's a privilege violation. You are not allowed to do that. All right. So you'll have to tell me who that is. I think I've told before, but I'm not sure I can find it. for 0. And LY, I think that's real initials. And Ollie, I know who that is. All right. So Ollie's won 3 times. All right, I'm going to stop this recording.